Okay, this video is a review, also a preview of radical expressions. Very soon in Algebra 2, you're going to begin to learn how to solve radical equations. So this part of the information, which you should have learned in middle school, depending on the curriculum that your previous schools had adopted, become very important. So some of it will be very familiar, others may be a little raw. And if so, just approach one of your classroom teachers. Okay? So perfect squares, what are perfect squares? Perfect squares are 1 squared, 2 squared, 3 squared, which is 1, 4, 9, 16, 25, 36, 49, and so on and so forth, right? Maybe 100 and more. Perfect cubes are 1 cubed, 2 cubed, 3 cubed. So that would be 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, so on and so forth. 7 cubed, I think it's 344, so on and so forth. Perfect fourth is, I think I need the help of my calculator soon. So 3 times 3 times 3 times 3. 3 times itself 4 times, it's 81. 4 times itself 4 times, 4 fourths is 256. And 5 raised to the 4th power is 625. So those are relatively easier because in middle school you've learned how to do squares and how to do cubes. You just multiply that base by twice or 3 times or 4 times. Now it's going backwards. How do we take a radical of a number? So here is a graphic organizer that tells you the different parts. This little n here is called the index. And the A is called radicand. Let me rewrite that a little bit better. So it's radicand. Oops, that's an A and D, radicand. Okay, and then the radical sign is what we all recognize. Notice that if there's no index, if there's no number right outside the radical sign, we assume that there is an invisible 2. So n equals 2 in that case. Now, the radical sign undo the perfect square. What do I mean by that? If I have 2 times 2 equals 4, right? So if I put 4 in under the radical sign, if square root of 4 should equal 2. Also notice that negative 2 times negative 2, negative 2 squared, is also 4. So these two have the same answer. Therefore, square root of 4 should also equal to negative 2. So in other words, when I take a square root, I should have 2 answers, positive number and a negative number. In fact, that is true for any kind of radical expressions with even number of roots. So square root, 4th root, 6th root should all have 2 answers. So let's look at some examples here. I have square root of 16, that should be positive and negative 4. Square root of 121, positive and negative 11. Square root of 289, positive and negative 17. Okay? Now a fraction, square root of 4 over 25, you're going to learn this property soon that you can split the square root, so numerator becomes positive and negative 2, and denominator becomes positive and negative 5, and you just need to write 1 positive and negative in front. It's okay. Okay? So cube root of 8, so it's 2 times 2 times 2, so that's 2. Cube root of 343 is 7. Notice cube root of a negative number. cube root of negative 125 is negative 5 because negative 5 cubed equals negative 125. And notice that for cube root, odd number of roots, the signs have to be consistent. And for the last one under cube root should be negative, and that should be 1 over 3. Fourth root of 1, we have positive and negative again because it's an even one. And 2,401, I think it's 7, isn't it? Positive and negative 7. And fourth root of 4,096, that's positive and negative 8. And finally, this one should be fourth root, so 3 on top, 2 at the bottom comes out. Okay? I'm going to move my paper upward a little. Okay, so here is a summary. So if I have an even index and it's positive inside, the number of roots, meaning the type of roots, meaning it's a real number, any kind of real number you've learned, and the number of roots is 2, positive and negative. If it's odd, so like 3, or a cube root, for example, and it's positive, then it's still a real number, and I only have 1 positive. If it's odd, that's negative, I still have real, but this one is negative. Oops. So you really have to, this one is negative. So you really have to pay attention here that for odd numbers, the final sign is consistent with the positive and negative number. That's called the radicand under the square root. Okay? Finally, I'm going to use a different color on this thing. For even roots, if the inside is negative, so for example, if I have a square root of negative 4, and the final answer is imaginary number, and you have not learned about imaginary numbers, and again, it's still 2, it's positive and negative 2. So in this case, it actually equals positive and negative 2i. You're going to learn about it in Algebra 2, but I thought that I would just write it out here so that you get exposed to it. This will not be on any quizzes in this year, but it will be in Algebra 2. Okay? So simplifying radicals. First one, I have 117. So it's all about rewriting the radicand by factoring it. So I have, if you factor it, you should have 9 and 13, and you're looking for perfect square here. And remember I said one of the properties is that you can combine or split the radical signs. So once you split it, I've got a perfect square here, so the answer should be 3 root 13. Nothing you can do about 13. It's a prime number, cannot be factored, right? So here I'm going to rewrite 320 inside, so I keep the 4 root 320, probably I have a 5 in there. If I divide it by 5, I should have 64. 64, I know it's a perfect square. So I have 4 root 5 times 8. And here, the whole numbers can be multiplied together. So my final answer is 32 root 5, or 32 times root 5. It's stated as 32 root 5. So in other words, when you have coefficients for radicals, just treat them just like how you treat variables. You treat the coefficients together. You multiply the coefficients together in this example. Okay, so the third one, I have 2. I have cube root 48. I recognize that 8 is a perfect square. And then after 8, I would have 6 left. 6 times 8 is 48. So it becomes 2 times 2, cube root of 6. I have 4 cube root of 6 there. Okay, I'll leave the last one for you guys to do. That's your final answer in this one. Second page, these are all different exercises. The I'm going to do number 6. If you look at number 6, I can rewrite number 6 into something like this. So now I have negative 6 cube root of 2. That's all. Okay, there's not much more you can do beyond that. So let me move this up a little bit. Radicals with variables. Again, these are Algebra 2 materials because it's got variables in there. It's not going to be in any of the quizzes, but I want to give you the option here so that you can get pre-exposed to it and see how you can do this. First of all, square roots. Exponents must be multiples of 2. And cube roots, obviously, the exponents, meaning the exponents of the, if I have this, I'm talking about the exponents of the variables. Those are the exponents. So cube root has to be multiples of 3. Fourth root, it must be multiples of 4. So here you just rewrite everything. Inside number 9, you have numbers and variables. Notice that if there's no radicals, there is an invisible 2 there. So I'm trying to change everything into perfect squares, right? So 32 is 32. I can rewrite that into 2 times 16 because I know 16 is a perfect square. And x raised to the 4th power, I'm going to do x squared squared. And y raised to the 9th power, I know I can rewrite that into y raised to the 8th power times y, right? So then I'm going to rewrite this again. 2 times 4 squared, the x squared is already there. And if I want y squared, y raised to the 8th power, I have to rewrite it as y squared raised to the 4th power. And then finally, there's 1y. Now I know I can take this out of the radical and then bring the base out, the base or the radicand out, right? The base is 4. I can take this out. I can take this x squared out. I can cross this out, but I take the y squared out. Well, actually, it's the other way around. It's y raised to the 4th power. And then what I have left is square root of 2y. Okay, so in other words, what I'm doing is, notice that I'm trying to write everything into the power of 2. If I can, I'm going to switch these two. I can switch this. It's easier that way. So if I have it raised to the power of 2, because of the square root, these 2 cancels and the base comes out. Whatever doesn't get picked, like the 2, number 2 and the variable y, they stay in the square root. So let's do another one. Number 10, 324 a cubed and b raised to the 7th power. So I know 324, if I use my calculator, is actually 18 squared. So I'm going to rewrite that. Now a raised to the power of 3, a cubed. I have a squared there times another a. And then b raised to the 7th, I'm going to look at b raised to the 6th because I want it to be a square, right? And then I add another b, so now I have b raised to the 7th power. So the 18 comes out, this a comes out, and what's left behind, it's a, I'm going to move the b, last b forward, and then b raised to the 6th power, I want that something squared. B raised to the 6th power is b cubed squared. So in this case now, this b cubed can come out. What's left in the radical is just a times b. So that's the final answer there. Okay, so this part is a little bit challenging. I will pick 3 more questions on this page and finish it and see how you feel about it. Again, this is actually for Algebra 2. I just want to throw it in here. We're going to give you more practices during class to tackle something that's a lot simpler than this without the variables. But the fundamental theories are exactly the same. Properties and principles are exactly the same, that you look for in the case of square roots, you look for the perfect square and then you make sure that the square and the square root cancels each other, the base gets out of the radical. But if it's a perfect cube, if it's a cube, you look for the cube and cancel it with a cube root, so on and so forth. All right, guys, I will see you in class. Bye.